Hi there, hope you have a fantastic day today. This lesson, I'm going to teach you how to solve problem involving projectile motion. So let's go straight into it. A particle is projected from the ground with an initial velocity of 30 meters per second at an angle of 30 degrees to the ground. So part A, how long is the particle in the air? Part B, what is the maximum height of the particle? So first of all, let me just draw the diagram out first. So we have, of course, horizontal component and vertical component. And the particle project into air and fell to the ground. So we have the initial velocity is 30 meters per second. And the angle to the ground is 30 degrees. There you go. So part A is asking how long is the particle in the air. So in another word, we need to find the time when the particle start project and hit the ground. So this is to find the time. So in another word, when RT, which is the displacement, the vertical height, okay, equal to 0. So in another word, the vertical component equals 0 for the displacement. And second part is the maximum height here. So we need to find the displacement for the y component. So to do this, we know that at that point, that is Vt is equal to 0 for the vertical component because the particle gone up all the way to at the maximum height and it stopped. And then it fall down. So therefore, to find the maximum height, we need to find the velocity equals 0 for the vertical component first, okay? So in order to answer these questions, so let's just find the displacements of the particle first, and then we answer all these questions, okay? So to do this, so we have a vertical velocity. That's for initial, okay? And we also have initial horizontal velocity. Now to work out horizontal initial velocity, we have adjacent and we have hypotenuse. So therefore, we have cos of 30 degrees is equal to adjacent over hypotenuse. So that is 30. Then what we do, to solve this, I times this by 30, I times this by 30. So this cancel out. So therefore, the initial horizontal velocity is equal to 30 cos of 30. And we know that cos of 30 is root 3 over 2. So that is equal to 30 times by root 3 over 2. So if I simplify this, that give me 15, that cancel out. So that is equal to 15 root 3 meters per second. Now we just need to find the vertical initial velocity. So that is y dot if you like. So we have opposite and we have hypotenuse. So it's psi. So we have psi of 30 is equal to opposite, which is vertical initial velocity over 30. And if I times 30 both sides, then I times 30 here. So this cancel out. So therefore, y dot is equal to 30 psi of 30. And psi of 30 is a half. So that will give me 30 times by a half. So which is 15 meters per second. So now we just put in vector form. So the initial velocity, that is v0. The horizontal initial velocity is 15 root 3i. And we add the vertical initial velocity. So plus 15j. So please keep that in mind for me, okay? This is the initial velocity. Apart from initial velocity, we also have acceleration. Now for horizontal accelerations, so we know that the accelerations for horizontal is 0 because we ignore all the air resistance. And for vertical, we have the gravity of the earth. So that is negative g. So g is 9.8. So we can just write negative 9.8. The reason is because the particle, it projects upward. So therefore, the acceleration, it works against the particle. Okay, so that is negative 9.8. So now we have the acceleration, at, which is the horizontal component, which is 0I, plus the vertical component, which is negative 9.8 J. So that will give me negative 9.8 J. To work out the velocity, we just need to integrate the acceleration. That is, Vt is equal to integrate of At dt. So which will give me negative 9.8 J dt. Integrate 9.8 J, which is a constant. So that will give me negative 9.8 T J at a constant, which is C. But to find the value of C, which is find V of 0. So V of 0 is give me 0 plus C. So which is equal to C. That is V of 0, initial velocity. But we know that initial velocity is 15 root 3I plus 15J. So that is V of 0. So therefore, C is equal to 15 root 3I plus 15J. So that is V of T, that is the velocity, is equal to negative 9.8 Tj plus 15 root 3I and plus 15J. So now I just put the J component together. So that will give me 15 root 3I add 15 minus 9.8 T. And this is J. To find the displacement, so we just integrate the velocity. So R of T is equal to integrate the velocity dt. So to integrate this, so I just write this down, which is integrate 15 root 3I plus 15 minus 9.8 T J. So now we integrate this, okay? So that will give me 15 root 3 T I plus 15T minus, now integrate 9.8 T, it give me 9.8 T squared divided by 2. So that will give me 4.9 T squared. And J. Don't forget, we need to add a constant. Now don't forget, because the particle is projected from the ground. So that is the height, initial height is equal to 0. So when T equals 0, that means R of 0 is equal to 0. So this means that when the T equals 0, this component is equal to 0. This is equal to 0. And this is equal to 0 because T is 0. So 0 times any numbers will give me 0. So in another word, C is equal to 0. So therefore, the displacement, that is R of T, is equal to 15 root 3T I of course plus 15T minus 4.9 T squared. And that is J component. So this is the displacement of the particle. So now I can answer these questions now. So let's go back to here. The questions part I is how long is the particle in the air? So remember, so that is to find a T, that is when the displacement is equal to 0 for the vertical component. So in another word, this component here is equal to 0. So to find the vertical height, 15t minus 4.9t squared is equal to 0. So that is, I take the common factor out. So that will give me 15 minus 4.9t is equal to 0. So therefore t is equal to 0, or 4.9t is equal to 15, and t is equal to 15 divided by 4.9. So now I just put in a calculator. So I got 15 divided by 4.9. So the answer is 3.06 seconds. I just write down here 3.06 seconds. There you go. So that is the flying time for the particle. So part B. So what is the maximum height of the particle? Now remember, we have the particle fly from the ground, and then to find the maximum height, this is at this point. So this point, because it's a parabola, so to do this, there are two ways to do it. One way is we know that this t is equal to 3.06 seconds already. So what we need to do is we just halve that to give me the t. Okay? And then we just substitute the t value into the vertical component for the displacement. Okay? That will give you the maximum height. Another method is we know that we need to find Vt equals 0 for the vertical component. Okay? And then we just substitute t into the displacement for the vertical height. Okay? Which is the vertical component. So two ways to do it. So what I do, signify t here. So I just go 3.6 on the screen. All I need to do is just divide by 2. So that is 1.53. So just go t is equal to 3.06 divided by 2. So that will give me 1.53 seconds. So to find the maximum height, so we know this component here is a vertical component. So if we substitute t into this component, will give me the maximum height. So let me just write down here, maximum height is equal to this. Now we just substitute the t, which is 1.53, into the equation. So 15 times 1.53 minus 4.9, 1.53 squared. So I just put in a calculator. So 15 bracket 1.53 minus 4.9 bracket 1.53 close bracket square. So there you go. This is 11.48. So 11.48 meters. So this is the maximum height of the particle. Please pause the video and try this one yourself. So let me just explain the situation first, okay? So we have a missile fired from the ground. So the initial velocity is 1,000 meters per second. And the angle to the ground is 60 degrees. So let me just draw this first. So we have a diagram like this. So we have horizontal, vertical component. And the angle to the ground is 60. And the initial speed is 1,000 meters per second. And part A, the question is asking how long does it take the missile to reach maximum height. So in another word, they want to find the time when it's reached maximum height, which is t, this t here, right? So in another word, we need to find at this point, that is when the velocity, the vertical velocity equals 0, because it's gone up to the maximum as it stop and it gone back. So therefore, Vt equals 0 for the vertical component, okay? And part B, the question is asking the range, maximum range, because how far away from its starting point. So this is here. So we need to find T of this point first. Okay, let's say this is T2. And then we substitute T in to find the range, in another word, so X component or horizontal component, okay? So to answer these questions, the easiest way is we find the displacement first, okay? All the time, just same process. Every questions, work out the process and find the displacement first, and then we just answer these questions, all right? So let me remove this part B first. So now we have vertical initial velocity and we have horizontal initial velocity. So for horizontal, we have adjacent and hypotenuse. So that is cos. So just right here, cos of 60 equal adjacent, which is horizontal velocity for the initial one, over 1000. So therefore, the initial horizontal velocity is 1000 cos of 60 degrees, right? And cos of 60 is a half. So therefore, that is a half of 1000, if you like. So which is 500 meters per second. Similarly, for the horizontal initial velocity, so that is y dot is equal to 1000 sine of 60. So sine of 60 is root 3 over 2. So that become 1000 times root 3 over 2. So if you times root 3 over 2, we can cancel that. That give me 500. So therefore, the vertical initial velocity is 500 root 3 meters per second. So now we just write in vector form. So v of 0, that is initial velocity. So which is the horizontal component is 500 I plus the vertical component, so which is 500 root 3 j. Now, apart from vertical and horizontal initial velocity, we also have the acceleration, okay? So in this case, the horizontal acceleration is equal to 0. Remember, we ignore the air resistance. But then for the vertical, so the acceleration is equal to negative g, which is negative 9.8. That is the gravity of the Earth, because the missile is firing up onto the air, and then the acceleration is works against the missile, so which is negative 9.8. So which is, so A of t is equal to horizontal component is 0 and the vertical component is negative 9.8. So we just write negative 9.8 j. And to find the velocity, we just need to integrate the accelerations. So v of t, which is equal to integrate a of t. So which is integrate negative 9.8 j. And of course, dt. Then to integrate this, negative 9.8 j is just a constant. So therefore, we integrate that. So give me negative 9.8 tj. And do not forget, we need to add a constant. And we know that v of 0, so v of 0, this will give me 0 because t equals 0. So 0 times any number is 0. So equals c. But then we know that the initial velocity is this. So that means c is equal to 500i plus 500 root 3j. So just write this down. So therefore, c is equal to 500i plus 500 root 3j. So therefore, V of t is equal to negative 9.8 ti plus 500 I plus 500 root 3j. Now I'm going to put the j component together. So that will give me 500i plus 500 root 3 minus 9.8 t j. So this is the velocity of the missile. Now to find the displacement, what we need to do is we just integrate the velocity. So the displacement or the position of the missile, if you like, is equal to integrate of v of t. So that will give me integrate 500i will give me 500 ti plus integrate 500 root 3 will give me 500 root 3t minus, now integrate 9.8t will give me 9.8t squared divided by 2. So 9.8 divided by 2 is 4.9 and then t squared and then j. Don't forget, we need to add the constant. Now to find the constant, we know that the missile is actually fired from the ground. So that is the initial height is 0. So r of 0 is equal to 0. So in another word, this component here equals 0 because when t equals 0, okay? And this 0 and this is 0. So in another word, c is equal to 0 because r of 0 is 0. So therefore, r of t, which is the displacement, equal 500 ti plus 500 root 3t minus 4.9 t squared j. So this is the displacement of the missile. Now we need to go back. The questions is asking for the maximum height. Now maximum height, remember, is this point here. Two ways to do it. One way is we need to find the velocity for the vertical component equals 0. Or we can find the vertical height equals 0 and then with so for t. So let's make velocity equals 0. Okay, so the velocity, which is v of t. So this component here is equal to 0. So let me write this down. So 500 root 3 minus 9.8t is equal to 0. Now to solve this, I just move 9.8t on this side. So that is exactly the same as 9.8t is equal to 500 root 3. And t will give me 500 root 3 divided by 9.8. So just put in a calculator. So 500 root 3 and I divide it by 9.8. So t equal 88.37 seconds. So therefore, t equal 88.37 seconds. So that means when the vertical velocity is equal to 0. So to find the maximum height, so what we need to do is we just need to substitute t into the vertical component for the displacement, okay? So therefore, the maximum height is equal to, so 500 root 3 times t. T is 88.37 minus 4.9 times by 88.37 squared. Or I can just bracket it. There you go. So now I just put that in a calculator. So now, because I already have that on my calculator, so what I need to do is just go 500 root 3 times the answer. So we know that the last answer is 88.37. So minus 4.9 times the answer square. There you go. So that is 38,265.31 meters. So let me write this down, which is equal to 38,265.38 meters. So I can convert to kilometers and divide by 1,000. So which is 38.27 kilometers. So into 2 decimal places. There you go. This is the maximum height of the missile. So part B, the maximum horizontal distance. That is the range, okay? So to do this, so we know that the missile is going like this. And we already have the time. The time here is 88.37 seconds. Correct? So that is at the maximum height. So therefore, what we can do, we got 2 ways to do it. So the first way is we find the r of t for the vertical component equals 0. We solve for t. And then we substitute t into the horizontal component. Otherwise, I can also use this time, I times 2, because it is a parabola. So if I times this by 2, it gives me this t. And then I substitute the t value onto the displacement for the horizontal component. So let's get into it. So what I do, I just use my calculator, okay? So I go 88.37 times 2. So that will give me 176.74 seconds. So I just write this down. T is equal to 176.74 seconds. So to find the range, so we know that the horizontal component is 500 t. So I just write this down. So the distance, the horizontal distance, if you like, so 500 times 176.74. So now just put in a calculator. So because I already have that on the screen, so I just go answer times 500. So 88,370 meters. So 88,370. So which is 88,370 meters. Or I can write 88.37 kilometers. Correct to 2 decimal place. There you go. This is the answer. Thank you so much for watching. Bye.